Hey, welcome back to Math with Patrick. Today's October 22nd, and we're solving problem 295 from the Daily Epsilon calendar. And the answer today should be 22 because that's today's date. So this x right here should be the number 22. Seems like we have some kind of maybe fraction reducing problem because both the numerator and the denominator here are going to be pretty massive numbers. Once we learn what that number is, we can plug it in here, do a little bit of arithmetic, and we should get the number 22. So I think the first thing to notice about simplifying this fraction is that all of the integers in here are multiples of 45. It's easiest for me to see it in the 945 because if you count by your 45s, you're eventually just going to be counting by your 90s. And if you count by your 90s, you're going to hit 900. So I can see here that 900 is the same as 45 times 20. So 945 should be the same thing as 45 times 21. So that's still 945, and I'm still cubing it. But I do want to kind of get this idea on the page that all of these are multiples of 45. So we can kind of just count by our 45s to get to 1080, because another one, as in 22 times 45, another one would get us to 990, and then so we just need another plus 90, or another two 45s to get to the number 1080. So overall, that's going to be 45 times 24 here. Still going to cube it. And a lot of the time in this calendar, they put the current year in. And so I've worked with this number enough throughout this year to know that this is just the square of 45. So both of these are going to be 45 times 45 and then cubed. 45 times 45 cubed. Not sure why I'm using both the multiplication x and a dot. Let's go back to just the dot. Here, I think I could just distribute this cubed to everything. And essentially, this will let me factor out a 45 cubed from all of my terms. So let me just do that little distribution first. All right, all done. And then now we can factor out a 45 cubed on top, leaving just 45 cubed plus 24 cubed. And then we can factor out the same 45 cubed on bottom. And so we're going to get 45 cubed plus 21 cubed. And this is helpful just because I can cancel out common factors in the top and bottom. And so now my problem is a little bit more simple. And actually, now that these numbers are smaller, like the 45, the 24, the 21, I also notice that these are all multiples of 3, right? Because 45, that's going to be 15 times 3. 24, that's 8 times 3. Here's another 15 times 3. And then this is going to be 7 times 3. And so I want to do this part a little bit more quickly. Essentially, I can factor out and cancel any of these common factors. And since the 3 is in common, I'm basically going to be factoring out and canceling all of those 3 cubeds in all of my terms here. So now this is my reduced fraction. There aren't any more common factors. 7 is prime, and then neither of these have 7 as a factor. I think here, trying to think of the same idea of reducing fractions, I think I want the sum of cubes formula. I believe, so a cubed plus b cubed, I believe that's the same as a plus b, and then times a squared minus ab plus b squared. There's this acronym, I think it's SOAP, where this S stands for same, as in it's the same sign as before. This O stands for opposite, so that's the opposite sign as before, and then this AP stands for always positive. And this acronym is helpful because if we had a difference of cubes, then we'd have the same sign here and the opposite sign here, and then an always positive right there. So I can use this factoring to rewrite the numerator as 15 plus 8. That's going to be 23. And then whatever else goes here. And then we get a 15 plus 7. That's a 22 right there. A squared minus ab plus b squared. So a squared is 15 squared. That's 225. So that's going to be the same thing here and here. AB on top is 8 times 15. That's 120. AB on bottom is just 15 less, and so that's going to be 105. And then B squared on top is 64, B squared on bottom is 49. And here, I actually notice, see how the difference between these two numbers is 15? And so we're like subtracting 15 more on the top. But then the difference between these two numbers is also 15. So we're adding 15 more on the top. In other words, these two numbers are the same, and I don't really care to know what they are. I just know that since they're the same factor, they're going to cancel. So overall, this fraction, y, is just equal to 23 over 22. So let's plug that into here. X is supposedly equal to 1 over y minus 1. Y is, again, 23 over 22. Let's maybe simplify the denominator. We're going to get 1 over 22. And then any time that you have 1 divided by a fraction, you're essentially just going to get the reciprocal or the flip of the bottom fraction. X is going to be equal to 22 today. So there we go. That's today's date. That's great because we're supposed to get 22 for today. And we did. So I guess we're all done. Thanks for coming along, and I'll see you tomorrow. Bye.